You are listening to the InfoSec OSINT Show, episode 57. Thanks for listening. I'm glad you found us. The goal of this podcast is to share practical tips of what works and what doesn't in information security. Essentially, I want to turn our guest wisdom into practical tips you can use to improve your own skills. Today, I talk with Ben Dowling. He's the founder of Ipinfo. IP geolocation is something that most of us rely on every day, whether it's just to figure out what our natted public IP is, or because we have a web application firewall that's limiting access to our web apps based on geolocation. Attributing an IP to a specific geolocation accurately is really important. My three main takeaways from our conversation were: one, how geolocation works, like how they associate an IP address with a specific location, even when the IP is in space. Two, how they validate crowdsourced geodata. And three, how they attribute an IP address to specific companies. You'll enjoy those two things plus a bunch of other tips along the way. And with that, let's dive into our conversation. So what are the things that you can tell from an IP address?
So there's lots of data sets that we provide at Ipinfo, and the things that we put together that you can kind of query our service for. Where's this IP address located? And that is city or zip level specific. We're not saying, hey, it's at this precise location or at this street address, but we'll tell you, hey, this IP address is in Seattle. This one is in wherever it might be, and the zip codes and the other geographic attributes around that, right? So if it's in the US, what state is this in? What country is it in? What's the time zone and other attributes of the location? So the location based properties. Then we'll tell you ASN details. So who's responsible for routing to this IP address? Is it Comcast? Is it Apple? We do classification of ASN, so we'll tell you what is the primary type of usage of that ASN. So we'll tell you if it's a hosting provider, if it's a consumer ISP, if it's a business, or if it's an educational institution. We'll tell you if it's a mobile carrier or not. In general, geolocation tends to be less precise for carrier IPs because they use carrier grade NAT, and those IP addresses are pooled, and mobile phones obviously move around. So we'll tell you if it's a mobile carrier or not, and which one, and various carrier codes associated with that. We'll give you the company associated with it. So that sometimes matches the ASN. So say it's, hey, this is Comcast. Sometimes it's more specific than that. So it might be, the business that operates this IP address is maybe a customer of Comcast. So we can tell you, not in all cases, but in some cases, the actual company that operates that IP address and who's behind it.
So what are the security use cases besides, I guess the obvious one would be blocking from a specific geolocation, but what other security use cases are there for using geolocation data?
Yeah, so some of it can be used, like you say, for sort of like automated enrichment that you then may want to do rules against. Like you say, if you want to say, hey, I want to block all traffic from that maybe isn't from the US. So you want to get the country of the IP address and then say, hey, if it's not from the US, I want to block it. Or you might want to monitor, say outbound traffic and say, let's enrich this, or let's analyze this after, and say, were there any connections being made to non-US locations? But also, a common use case we see from the security industry is investigations. And so, it may be you've seen something in your logs or something, right? And there's been a bunch of, attempted logins or password failures. And then you may want to say, well, who was this? What was going on, right? And so there's the enriching the data up front. We're saying, okay, now we know, what country this came from, what ISP, what company, whether it's a mobile carrier or not. The type of traffic will tell you. But then you may want to enrich that further, and someone could use that and then do an investigation. Like, okay, we actually have had attempts to breach our network from this IP address. I want to find out everything I can from it. And so we also have we can provide we enrich all the whois data, so we'll tell you the abuse contact details. If you say, hey, I definitely had an attack from this IP address, I want to flag this to the network operator, and so we've got the whois details with the abuse contact details that just in a simple API format, and then you can reach out to those and report that. You can find out more about where may have this been coming from, the country, and things like that. And then some of the data points can obviously help with either removing false positives or flagging stuff. So the IP type data that we have, we can say, hey, this is, this looks like it's a hosting provider to us, right? So it's much more likely to be maybe, automated scripting or something versus this is coming from consumer ISP space. And then, that could adjust the risks. And so cybersecurity is a big use case there, but, we also see customers using that for things like, fraud detection or, for kind of giving a event a probability of it being risky.
So how do you figure out where an IP is actually located?
Yeah, so the geolocation data set is obviously the data set where we map all IP addresses to where we think they are in the world at a city level accuracy. And there's a bunch of different data sources we have that feed into that. And then obviously a bunch of algorithms that sort of crunch that data and come up with our data set, and we update that daily. But there's lots and lots of different data sources. So obviously the kind of the first piece into that data pipeline is all the IP whois data sets. It has all who's registered these IP addresses, who are they assigned to, where are those companies located, and that kind of lets you chunk up the all of the 4 billion IP addresses into chunks that are owned by different people, and then the ASN data obviously goes into that as well. Which one's mapped to where. That gives you a good first pass of how things are structured and the organizations that own them. And then beyond that, it's like, okay, but so how do we then see if these chunks are located together? How do we know if they're located where the company may be registered? How do we know if they might be somewhere else? So in some examples, that's all you need, right? For example, say a university, right? There's the universities often have all their IP addresses registered to a block, and it may be, I don't know, say Stanford University. They'll have a bunch of IP addresses assigned to them. Their whois address details may say, we're Stanford University, we're in Palo Alto in California, and that's exactly where those IP addresses are going to be operating from. And you can be confident that's sort of job done, right? But for on the other end of the spectrum, you may have, say, Comcast, and they have an enormous number of IP addresses. All of their whois data says, hey, our address is New Jersey, where the Comcast is headquartered, but that's not actually obviously where all of the Comcast customers are. And so there, to kind of bridge that gap, there are lots of different data sets that fill in between. We do active scanning of all IP addresses on the internet, and we take ping measurement data. Then we do IP multilateration, which will tell us where do we think, what are the bounds of where these IPs may appear. If we've got good coverage in our network, so we have with lots of servers in North America, lots in Europe, coverage in other areas is weaker. So there may be IP addresses where we can say, hey, this is definitely in Africa, but we can't get more granular than that. But we can cross-reference, the whois data we can cross-reference. Another data set we have is Traceroute data. So we'll look at traces to all IP addresses and then kind of see where do those traces go. We look at timing information there. We also look at hostname hints. So a lot of internet backbone infrastructure will have whether it's airport codes or city names, whatever, within the actual host names. So we look at those hints as well, and we extract those. We get data from other partners. So ISPs will sometimes give us data feeds, and so say, hey, here's a feed of all of the locations of our, here are the IP ranges, here's where they're located, and they give us data feeds for those. We have mobile SDK data, which will be aggregated and say, hey, these blocks are in these locations. And so all these sort of data sets feed into our algorithms. We look at whois data, we look at BGP data, we look at SDK data, we look at hostname data, we look at our ping timing data, and then there's all sorts of ranking, sorting, filtering, and then the end result of that is for sets of IP ranges, we map them to locations.
So how often do these data sets change? Like if somebody reboots a router and then the IP gets assigned to a different country, how quickly can you pick up on that?
Yeah, so we update our data sets every day, and it's obviously seamless to our customers that are consuming our data through the API. We push out updates, and the API will start returning fresh data. And so, if an IP address was to change right now, we would pick up on that. Hopefully, within 24 hours, that change would be live. Now, in reality, obviously, that it depends on a lot of IP geolocation stuff. Depends on the actual ISP or the company behind it, right? And so, Stanford University, those IP addresses are probably always going to be in Palo Alto. They're relatively static. Even if someone within Stanford got the IP address change, it's just going to be allocated to someone else at Stanford and not likely to change. For an ISP, it may be the case that they say, hey, these are the IP addresses that we assign to Seattle, and I may reboot my home internet router. I'm going to get a different IP address, but that's gone back into the pool for Seattle. And so even though there's a change of the device and the home that the IP address is assigned to, it may be assigned to the same location, and that's commonly what we see, right? So they're not just going to suddenly Comcast, for example, won't just suddenly say, hey, this is IP address that someone's rebooted their router, and now we're going to go give it to someone in Miami. But that's not necessarily a property of the IP, right? That's just a property of how Comcast run their network. And so there are IP geolocation accuracy and timeliness can depend on who the ISP is, how they decide to run their network. There's no necessarily inherent property of an IP address that says, hey, this is in Seattle, it has to stay in Seattle. And so there's lots of different things that we have to do to try and pick up on these changes, to try and detect them, to try and group them and say, is this IP address in a set of IPs that all happen to be in Seattle? And so some things that we look at internally are, what's the stability of an IP address? How frequently does it change? But yeah, in general, IPs don't change location too often. I think we see that on the whole, our data sets change about 5% a day, about 10% a week. I think it's about 15 to 20% a month that we see changes. And that's at the city level. At the country level, the changes are even less frequent. What we are seeing is that IPs is the amount of changes picking up over time. Obviously, there's the exhaustion of unallocated IPv4 addresses, and so what we're seeing is more and more. There's more and more activity in people buying and selling IP addresses, and so whole blocks that maybe were some ISP in Europe may have just sold a bunch of IPs to AWS, and so then you've got bigger changes, right? It's not just like, okay, this is Comcast that had this block assigned to Seattle last month. They're seeing actually more demand in Miami, and then they reallocate a block to Miami. What we're seeing is, okay, what was this was an IP address that was used in say Germany for consumer ISPs, is now used for AWS in Oregon or wherever it may be. So we're seeing more and more changes like that, but that doesn't happen. It's not like this is happening within a day, in a day-to-day, right? The changes don't tend to happen hourly, and so the daily changes tend to capture pretty much everything, and the changes tend to be not dramatic changes like that.
So how would you? I was going to ask you how you handled like IPs in the International Space Station, but I think a better question may be something like Anycast. How would you attribute that? But maybe explain first what Anycast is.
Yeah, sure. And I can get into the space station and all that the SpaceX and everything as well, which is an interesting topic. So yeah, I mean, Anycast is we talk about geolocation assumes that an IP address has a geographic location, right? That an IP address appears somewhere on the globe, and that's generally true of most IP addresses, right? There's I'm sat in my office here. My office has an IP address. It's just used by me. I have a physical location, and so it makes sense to say, hey, my IP address is in Seattle, right? That's where I'm at. For Anycast and a bunch of other cases, that kind of property breaks down, right? And so Anycast is an IP address that doesn't map to a single device, and there are lots of popular Anycast IP addresses that are commonly used, DNS servers, right? And so Google's public 8.8.8, Cloudflare have 1.1.1.1, and I think there's the 9.9.9.9 that's run by IBM, I think. And so lots of these kind of public famous DNS servers, they don't map, that 8.8.8.8 doesn't map to a single Google load balancer somewhere, right? That maps to lots of different load balancers all over the globe, and 8.8.8.8 and IP addresses like that are Anycast IP addresses. And so you can type that in, but there's some sort of magic that happens behind the scenes that just means that doesn't map to a specific device. And so those Anycast IP addresses are special. What we do is we do Anycast detection. So as part of our global probe network, we ping all IP addresses, and then we can detect Anycast addresses because it defies the laws of physics, right? We're seeing that we're getting low ping times from all around the world. It's not possible that this maps to a single location, and then we return that in our API, and we say, hey, we've detected this as Anycast. We do still return a location, and in that case, we return the location of the organization that owns that IP address. For Google, we'll say, hey, this is Mountain View, California. But we include the caveat that it's Anycast, right? So it's not really in California, but that simplifies handling for people where they don't want to have to handle the edge case in their application. They may just want to show a default location or do something with it, and so we give them a location and we'll say, hey, this is California, but there's the caveat there that it's Anycast. And so that caveat also exists for other things, right? So Anycast is a great example where it's like, this isn't really in one location, right? This is in a bunch of different locations, and the thinking of that IP address with a location sort of breaks down. It's a more fuzzy concept. And so the same is true for sort of carrier IP addresses. Some carriers will just say, hey, we'll pool our IP address to all of our customers, not only wherever they are in a country, but say they're roaming. So when you're roaming and say you're going abroad, you're taking a mobile phone, your traffic still gets routed back through your home network, right? And so I'm on T-Mobile here in the US. If I go back to the UK and visit the UK, I will still have a T-Mobile US IP address. I will still be geolocated to T-Mobile in Seattle, but actually I'm in the UK. And so the concept of IP geolocation can break down through mobile carriers. It's generally true that most of the customers will be in the US, and then so some carriers as well will pool it geographically. So they may say, here's a set of IP addresses we have for the state of Washington. Here's a pool of IP addresses for a different state. And so again, we include that flag, right? So in our API, we'll say, hey, this is a carrier IP. It belongs to T-Mobile. And so there's a caveat there that, the location-based information is somewhat holds, right? This is a US-based carrier. But it's unlikely that the location is exactly where the user is based. And so there are other you mentioned space, which is a good one. So there's the Starlink from SpaceX. The way that they've structured their network is they route customers through IP addresses based on the country that they're coming from, and then we have a feed from SpaceX where they tell us, hey, these IP ranges correspond to users with rough proximity of these locations, and so map them through here. So that's one where some of our active measurement stuff would break down, but they give us a feed and they say, hey, look, the reality is that this is in space, but the way that they are going to manage their network is to route customers based on the customer's billing address and things through these specific ranges, and so that kind of means that IP geolocation doesn't break down, so it's kind of managed that way. That's another example of where it just happens to be that they run their network that way, right? It could be that they just said, hey, we send all of our customers through this one IP range, and the whole concept of IP geolocation is going to break down there. But we could then still give you attributes that say, hey, heads up, this is actually coming from space. And VPNs is another example, right? And so we do VPN detection, and we have that flag in our API where we say, for VPNs, we can often detect the location of the VPN endpoint, right, using all the other data sets. And we could say, hey, this is a server in Germany, this is a server in Seattle, and this is where we've detected the location of this IP address. But right, we've got people from all around the world connecting to this through this endpoint, and so we'll give you a flag and say this is a VPN. The traffic is coming from Seattle, but that's probably not where the user is. I think that's in these cases. Well, there's a set of IP addresses where the user location and where the IP address is located is the same thing. And so I'm on this IP address, I'm in Seattle. Those two things are the same thing. In some cases, where the IP endpoint is and where the user is are actually disconnected and they become different things. So carriers are one example, right? T-Mobile in Seattle, I may be a user and I'm in Seattle right now, but if I go on vacation, go to the UK, those things kind of get separated. And there are other examples like that, so VPNs, Anycast, and things like that. And so what we try and do is always return a location, but also include the caveat that hey, that there is this may not, in this case, represent the end user location, and here's why, right? It's a VPN, it's a carrier, it's something in space.
So how would you know it's a VPN?
So the VPN detection, we do a bunch of different things. We do, as part of our active scanning network, we try and detect which servers may be running VPN software. We do behavioral stuff. So
you're port scanning the internet essentially.
We do port scanning. We do VPN handshakes, right? So we see what servers want to VPN handshakes and a bunch of other stuff to try and detect which ones look like VPNs. We do behavioral based stuff where we see, we've seen a bunch of different users from different locations, and so we'll look at that. We look at things like we look at VPN config data, and so there are a bunch of different things go into do we have any evidence that this either is or has a probability of being a VPN? And then we kind of flag that as say, hey, we think this is a VPN.
How'd you get started with Ipinfo?
Yeah, I mean, somewhat by accident. So I was just using sort of off the shelf free geolocation data for a bunch of different projects, just side projects that were for fun. And it was a pain to download the data, keep it updated, run a cron. And I was doing this on a bunch of different servers, and the cron would fail on some servers or whatever. And so I just thought, well, hey, instead of doing this a bunch of times and it's getting frustrating, why don't I just set this up on one server and wrap it in a simple API that then I can use on other projects and other developers can use. And so, just kind of removing the headache of getting set up and using geolocation data. I was like, hey, let's set up a simple API that can do this. Launched it as a free API, and it started getting some traction. And we quickly started getting feedback saying, hey, I love your service. The API is great and reliable, but your data sucks. And I would say, hey, it's not our data, right? We're here to make it easy to use and have a nice API, but we're not in the data business. Go give your feedback to anyone that kind of produces the data, and we'll eventually get those updates and it will be improved. But after keep hearing this feedback again and again and again, we said, okay, well, can we just fix this data, right? I'm sure we can kind of come up with some improvements to it. And that started, a very long road of producing our own geolocation data sets and other data sets as well, right? And so some of the caveats we've talked about was like, oh, well, yeah, this is really a server in Seattle, but it's a VPN. And so there's this difference between where the server's located, where the user's located, solving some of those pieces as well, right? Where people would say, hey, you're telling me it's Seattle, but, actually, a user's signed up and they've told me that they're somewhere else. And we'd go and look at that and say, well, was this an issue with our geolocation data, or is there some other explanation, right? And so some of those things, it's like, actually, yeah, no, we were right. The server is really located in Seattle. Our geolocation data is accurate, but the reason you're seeing something else, or reason you didn't expect this, is because it was a VPN. And so then we'd say, okay, well, let's go and see if we can give you that data as well, and Anycast and all those things. And so, it's just been kind of an ongoing process of how do we improve our data? How do we kind of cover some more of these cases where there's discrepancies? How do we improve that data and kind of cover more?
How do you crowdsource some of the corrections then?
Yeah, so exactly. So that was the kind of the first layer of improvement, right? People would come to us and say, hey, you're saying I'm in, San Francisco, but I'm in, I'm in Austin, Texas. And so we'd say, okay, well, fine. We'll keep track of that, right? And so we just have a database of corrections.
And then how do you verify what they say is correct?
Well, so initially we didn't, right? We're just like, okay, great, thanks, right? If you've gone out of your way to tell us that you're in Austin and you care about it, that's what you want it to say, right? So we'll just go do that. That grew initially from end users saying, why are you saying I'm in the wrong place? Can you say I'm in the right place? To ISPs giving us feedback, right? They come to us and say, hey, we've had our users complaining because, they're trying to use this website, and say the website would be a customer of ours at that point, and, they're not able to, watch videos or whatever because it says that they're in the wrong country, or they're not able to do this because it says they're in the wrong state. Can we help you with your data, or, can we collaborate on kind of making sure that your updates are timely? And so we get feeds directly from ISPs. And to a point where we would, it became adversarial, where people would say, hey, can you kind of show that our data's in a different country because, for whatever reasons. And so then begin the process of actually verifying that data, right? And or we might even have conflicting data, right? We might have somebody come to us and say, hey, actually this whole block is here, and we'd have someone else and say, hey, this whole block is there, and we'd say, wait, hang on, right? Who's actually responsible for these locations? Who's right? And so so a lot of the verification comes in from the active probe network, where we'll ping the data. If someone's telling us it's in New York and someone's telling us it's in Rio de Janeiro, well, when we ping it from New York, it's under 1 milliseconds. We ping it from Rio de Janeiro, and it's hundreds of milliseconds. We can be confident it's in New York. And so that's a lot of the filtering and the stuff we do with our probe data. I mean, there's still an element of trust. There's sometimes ISPs will send us geofeeds, and we say, hey, we've tried to verify this. You're saying it's somewhere else, and it's not. And they might say, yeah, but it will be, right? We haven't. These IPs are going to be online next week, and we're moving them, and so we want to make sure it's a timely update. And so sometimes we say, fine, we can override this. The SpaceX one's a great example, right? We're like, these IPs don't look like where you say they are. And like, no, of course, because they're in space, right? But this is where this maps to where our users are going to be based, and so it makes sense to do this. And so sometimes the verification process fails, but we say, hey, you're a trusted source, and we accept your data. For untrusted sources, we do that verification process, and we try and keep as much as we can.
You have another project, Host.io, which looks really interesting from a security standpoint. Can you tell us a bit about what it is, and how is it different from other, let's say, it's not really asset inventory, but how is it different from the other asset inventory services?
Yeah, sure. So the Host.io came out of some of the work we're doing for Ipinfo, right? So one of the data products on Ipinfo is IP to company matching, right? And so we'll say, hey, you're given this IP address, what's the company that owns or operates it? And for that, we take a lot of WHOIS data. We do a lot of enrichment and say, what are the entities there, and what's a domain that's associated with that. And so, as part of work, we were taking a bunch of domain data and trying to find which are, and trying to match business entity names to domains, right? And so, given the string Comcast, what is Comcast, right? And you say, well, there's Comcast.net in a bunch of WHOIS records. There's Xfinity.com is their public-facing, website, and there are all these different entities. And so, trying to solve that problem was one of the things we were doing as part of our IP to company. And in the process of doing that, obviously we scraped a bunch of domain data, doing a bunch of processing and stuff around domains and trying to solve that problem. And we had all this data, and we were updating it regularly. And talking to some of our customers about some of the work we're doing around IP to company, they said, actually, I just want to get my hands on that data, right? That would be really useful for me. And you've got all this HTML for these domains, you've got the links between them. And so we said, well, actually, yeah, we've got this data that we were doing as part of IPD company, but there's value in this data set itself. And so we kind of launched it as an API and exposed a bunch of the data we had internally. And then, worked with some early customers where they said, hey, this is great, but actually, can I get the backlink information that is implicit in your data, but I would love to have that as an API field. And so we launched this as a product, and the data set is basically the data that we already had, right? And we've mapped them into an API. So the data, we go and scrape every domain that we know that's registered once a month. We scrape all that data, we do DNS resolution, and then we cross-reference it all and make that easily accessible through an API. So it'll be things like, the things that you can ask of it are, give me all of the domain names that have, say, this Google Analytics ID, or give me all the domain names that have this name server, or give me all the domain names that have this IP address, or for a domain, give me all the attributes that you have for it. Or return, hey, this domain name is hosted on this IP address, it has this ASN. We include some of the Ipinfo attributes, so the geolocation of those IP addresses. We include if there's any copyright messages on the domain, if there's any what's the title, and some basic HTML properties, and then some of the IDs, right? So what's the AdSense ID, what are some of these other IDs? And then, you can use that to a bunch of use cases. Your cybersecurity use cases might be you've seen a domain and you want to kind of get an assessment of, does this, or maybe you've got a domain, you want to find out more about it, right? And so we can give you the title if there's HTML.
Or just scope out an engagement,
right?
Which is classic, right? A company says, here's what we own, run a pen test on it, and they actually own a couple other servers they just weren't even aware of.
Yeah, and so the redirects and I mean that has been really useful. So, and we've actually often find really interesting stuff, right? So what are domains that redirect to other domains on the internet? That was a useful property for us to say, well, which one on the Comcast example, right? What do we want to attribute Comcast with, right? And so there's Comcast.com, .net, all these crazy ones, and so the redirects can be useful if a couple of them redirect to the other one. That other one's probably more important. And one thing we built out around that as well was domain ranking, right? And so we took a bunch of our different data. So what are the redirects, and all these other properties, and then came up with a ranking. And so that's a free data set we released as well. The Hosto top 10 million domains, where it's like, hey, based on all our properties, here's just a list of 10 million domains that are ordered. And then that ranking as well helps us with the IP address data and a bunch of different stuff.
Traditionally, I've always used like curl requests, and I guess I'd be under the individual users. Just curl ipinfo.io, get my IP, see where I am. What other ways can I access the data?
Yeah, so curl is a great way in that. I mean, that's how a lot of people access our data, right? And we have the unauthenticated API to make that really easy, right? You don't need to sign up for an API token. You can just hit curl ipinfo.io and we'll give you some data. That we have a bunch of SDKs. So if you want to write some code, if you want to use it in production on a website, we've got a bunch of SDKs that make that really easy, and for all sorts of different libraries. We recently last week released a command line interface, so you can now just install the Ipinfo Client, and we actually added a bunch of really cool functionality to that. So you can just type Ipinfo my IP, and we'll basically give you the same data that you get from doing curl ipinfo.io. But we added a bunch of really cool functionality to that. So some of the things, we added a grep IP command. So it's like, hey, you're on the command line, let's just make this tool as useful as possible. And so I kept seeing a bunch of examples where people were putting together nasty regular expressions and things to try and get IP address out of logs. And there are these hairy regular expressions, and that's before we get into IPv6, right? And so it just becomes this whole mess. So we built that into a really simple performance tool, so you can use our command line tool to grep IPs as well. A cool tool we recently launched as well was ability to just map IPs, and so you can just kind of pipe a bunch of IP addresses to us, and we'll give you a really sexy map that shows where they are, and you can zoom around and stuff. We bundled that into the command line tool as well, so you can just cat a bunch of IP addresses into Ipinfo map, and we just return a URL, and you can click on it and see the map. And we made it really performant as well to look up to summarize a bulk data. So we have a bulk API endpoint that takes 1,000 IPs at a time. You can call it more times if you have more than 1,000 IPs, and we kind of encapsulate all that into the command line interface, so you can just cat unlimited number of IPs into Ipinfo summarize, and we'll give you a great summary. So it'll be like, here are the top countries, here are the top ASNs, just give you a really nice overview of the data. Or you can pipe it into map, or you can actually get the full data for those IPs. So if you don't want the summary, you want the actual, the full Ipinfo lookups for that, you can do that through the command line tool. That's the quickest and most efficient way to do that. And then through our website as well, lots of people use us through the command line interface with curl, through SDKs and libraries. But the simplest way to get our data is probably just go to our website, right? And you can type in any IP address, you can do whatever, and we'll just show you the data there if you just want to kind of do a quick investigation. And we've got the summarize tool built into the website as well, so you can just paste in a bunch of IP addresses. We clean those up, so if you just want to copy and paste the whole website, if there's some IP addresses in there, just paste them into the summarize tool, hit summarize, and we'll give you the same sort of overview you get through the command line. So we'll tell you, the percentage of countries, the type of traffic, and on the summarize, we give you all of our data attributes. Like I said, some of the VPN and carrier stuff is only available in our higher tier of paid plans. But on the summary, we include all that data. So we kind of say, hey, 20% of these IP addresses were VPNs, or 5% of them were carriers, and we give you a breakdown of what those carriers are. And on the summary tool, that's available, for free for everybody.
So let me ask: now that you have a couple SaaS products under the belt, what advice would you give to someone who wants to start a security/SaaS company?
Well, I think one thing that has worked well for us is giving away that free data, right? That really helped us get that sort of initial traction and kind of prove the demand and prove that it was useful. I know often the advice is, charge more and make sure that people are paying for it, which I think is also good advice. But I think, giving that stuff away for free initially, you kind of prove the demand, prove that it was useful, and then it was very easy to kind of layer in pricing after. I think that really helps to kind of get the word out on the data. It's a very low barrier to entry then, right? I mean, we'd see in the very early days of Ipinfo, people were writing SDKs for us, right? And we're like, hey, I love your project. I'm going to start using it in PHP. I see you didn't have a library. Here's a library, right? And so that's a kind of a great way to get people trying out your data, right? And I think if people don't find it useful when it's free, then it's going to be a very hard sell when it's paid. So that's been a good way for us to say, hey, it's free. Come get it, play with it. If it's useful, then you can kind of figure out a way to structure it where it's okay. Well, what is the bit that people can use straight away, and what are the ways that we can kind of make the more valuable pieces, restricted or separate that out into a paid plan.
So the freemium model has been very successful for you.
Yeah, that's been a good model for us, and that's one I would definitely recommend.
Where can people find you if they want to learn more about what you're up to?
Yeah, so the website is obviously ipinfo.io, and that's a great way to kind of come and see all of our data. We're on Twitter as ipinfo.io, and I'm personally on Twitter as Codaholic, and yeah, they're the best places to find us.
Great. Well, Ben, thanks so much for coming on the show.
Yeah, awesome. Thank you.
All right, that's it for this week. Thanks again for listening and for leaving reviews. I'm at Jamoose on Twitter, or drop me an email at podcast@breachsense.io. And if you're part of a security team that needs visibility into your clients, employees, or third-party suppliers' breach credentials before criminals exploit them, then head over to breachsense.io to apply for a free 7-day trial. That's it for this week, and I'll be back in your earbuds next Thursday.